Thank you guys. I flew in from Napa, California yesterday, and I'm really excited to see so many faces in the audience. This is really cool. So today we're going to talk about artificial intelligence and some of the really cool stuff that's been going on in the news lately. Okay, so a little bit about me. I'm a software engineer. I specialize in artificial intelligence, and I have written code that is now in use by many Fortune 500 companies, including BMW, eBay, LinkedIn, PepsiCo, and GoDaddy. Okay, so let's talk about what artificial intelligence is. There's a lot of rumors and a lot of stuff swirling around. So what is AI? Is it going to kill us all? Probably not. I don't think so. Okay, so artificial intelligence is simply getting a computer to do something that normally requires human thought. So for instance, a self-driving car, normally driving a car requires human thought, and since we're programming a computer to do it, that's artificial intelligence. Okay, so there are many different kinds of artificial intelligence. There are 5 or 6 branches. The most important branch right now is called machine learning. It's where you program a machine to learn on its own after you give it some information. So it's like, let's say you have a very smart child in a schoolroom. You can either teach that child by standing up at the chalkboard and saying, hey, do this, or you can give the child a book and tell the child to learn on his or her own from that book. And this is what machine learning is. It basically programs a computer to teach itself. And it's a lot faster and more effective than other types of artificial intelligence. Okay, so machine learning can be divided into 2 separate camps. There's classical machine learning, which is based on statistics and probabilities, and then there's deep learning. And deep learning is really cool because it uses a program to learn, and that program is based on how the human brain learns. In your brain, you have neurons, and these neurons zap little bolts of electricity back and forth to each other, right? Just like this. And that's how we communicate, that's how we think, that's how we learn. In an artificial brain, in a program, you have these artificial neurons and these artificial synapses called weights. And instead of zapping little zaps of electricity back and forth, it zaps numbers, right? And those numbers show how big the zap should be, and then it'll go on to another neuron. So these neurons and these synapses come together, just like a brain, in a very complicated network, okay? So it's just basically numbers going in and numbers going out. That's basically all artificial intelligence is. That's all deep learning is. It's just numbers going in and numbers going out. So why is this important? Why does this matter? Because of something called function approximation. So if you've ever seen one of these, it's you put your hand into it, you can make little shapes out of it. It's not a hand, but it's close enough to a hand that you can tell what it is. And that's what deep learning is. It approximates a function. So let's say there's a function in your brain that lets you tell, that lets you turn an image of a cat into the word cat. So every time you see a picture of a cat, you know that it's a cat. That is a function somewhere in your brain, some kind of mathematical function that takes an image as an input and outputs the idea cat. Okay, so what deep learning does is it approximates whatever that function is. It gets as close as possible to it. So here's an example. This is just a simple function, y equals x plus 2. You have your input is 1, output is 3, 5, 7, etc. So whatever you put in, whatever gets out, or it outputs that number plus 2. Okay, so a deep neural network is a little bit different because you have the inputs, you have the outputs, you know the question, you know the answer, but you don't know the function. So what you do is you train this program, remember we talked about it's called machine learning. So you train this program to learn what the function is from the inputs and outputs. The problem is you need thousands and thousands of inputs and outputs, so you need a lot of data, but it's still worth it. Okay, so a deep neural network, which is what we talked about with the brain program, it learns by connecting inputs and outputs. Okay. So we're going to talk about how you train a neural network. I know this is a lot, like you guys just came here for news, but I feel like it's really important that people understand what AI is so that you don't, have all these misconceptions, and when your friends say, oh, AI is going to kill the world, you're like, no, AI is a very very specific type of programming that does this and this. Okay, so how do you train a neural network? Training is getting it to figure out what the function is. So you show it an image of a cat, or many images of a cat, and then you give it a word. That's a label. You say this image is a cat. And then you show it a snake. You say this image is a snake. You show it a person, and you say this image is a person. Right? Yeah, see, that's a gorgeous lady that I found on the internet. You're the first audience to laugh at that one, by the way. I'm very happy that you did. So after you trained this AI on all these images, let's say you have 1,000 images in each category, then you say, okay, brain, what is this? And then you hope that the brain will give you a correct answer and say it's a cat. And often it will give you a confidence figure. It'll say, I'm 99% sure this is a cat, or I'm 50% sure this is a cat. Okay, so that is one way that we can use that function approximation, making this function. So another way is sentence completion. So if we put in 3 words, go to then the AI might output the word store. And that's called text generation. And we'll get more into that later. It's really, really cool. Another thing is called reinforcement learning. You are given a situation, and then the AI takes an action. The AI is given a situation, or maybe a photo of a situation, and then it chooses the best action. And that's called reinforcement learning. And we use it to beat video games sometimes. So if you see in this image, you've got Mario, and he's underneath the mushroom, and everybody knows that in Mario, these mushrooms are really good for you. So if the AI receives this image, then it's going to go into that function as X, and then its output is going to be, okay, I'm going to command this character to jump. So that's reinforcement learning, and it's doing some amazing stuff right now. In fact, Terminator, you know the movie Terminator, where an autonomous robot was programmed to go back in time and kill one person, that became real 2 years ago, except for the time travel part. All right, so we're going to talk about natural language processing with GPT-2, GPT-3, and Matt2Beck, a jukebox, and OpenAI codex. Then we're going to talk about computer vision with StyleGAN, DollE, PyTorch 3D, perception, and transformers. And I know these words don't mean anything to you yet, but they will by the end of this talk. We're going to talk about AlphaGo, AlphaZero, BlueZero, OpenAI 5, the Terminator drone, and a little idea called reward is enough. Okay, so natural language processing. This is anything to do with AI and words. All right, so GPT-2 is the first AI program to generate text that feels human. And the idea is, if you input 80 words, what should the 81st word be? And then after that, you take those 81 words and you run it back to the machine, and you say, what should the 82nd word be? And so it keeps using itself as an input, and then generating an output, using that one back. So it keeps cycling over and over again until it just generates long sentences. So the company that made this, called OpenAI, it was founded by Elon Musk. So they thought that this would be too dangerous to release. They thought if they released it, the internet would be filled with all of these, fake articles. But actually, it came out anyways, and that didn't happen. I mean, people are just using it for kind of fun. Like, I've used it to create jokes. I've used it to create satirical news headlines. I've used it to create product names. It's pretty cool. You can train it on any kind of text you want. If you have like 100,000 lines, you can do Shakespeare. You can do sci-fi novels. You can do whatever you want. It's pretty cool. The only problem is it can't remember more than 80 words in the past. So you can't do like a whole story arc that's cohesive, but you can do short little things, like taglines for advertisements. Okay, so GPT-3 is the newest one. This model is 10 times as big as the previous one, and it's really, really cool. So what you can do is you can just type into it what you want, what style of text you want, and it will return that style of text. Like you can say, give me a business name for a startup that does AI for stock trading, and it will come up with a list of business names. It's pretty cool. Yeah, and it can even generate code. If you say, write out in code for me a website that can do this and this and this, and you press enter, it will do a wall of code that you can actually run. So that's really cool, and it kind of puts my job in danger, unfortunately. So hopefully that doesn't get too much much better. Okay, so this is really amazing. This is called Mat2Vec. When this first came out, I was completely blown away. So this research team, sponsored by Toyota, created an artificial intelligence machine that would digest millions of research papers and then come up with its own new research. And so there are these things called thermoelectric materials. They change temperature when you run electricity through them, or if you change the temperature, then they shoot out electricity or something like that. I'm not too familiar with them. But there are a finite number of thermoelectric materials that we know about. So this group, they ran 5 million research papers on thermoelectric materials through this program called Mat2Vec. And then the program spat out 10 new thermoelectric materials that had not been discovered yet. So they've actually been testing these thermoelectric materials that were discovered by this machine. So it's just a really, really cool idea that you can put in human knowledge and get out even more knowledge. All right. Okay, so this is another really cool one. It's called OpenAI Jukebox. And it can generate entire songs in any style by any popular artist using any lyrics you type in. And it's not just like a MIDI ding-dong-ding thing, it's full audio production. You can change singers or styles, you can change genres, you can generate from real songs or scratch. And just to give you an example, so Louis Armstrong lived from 1901 to 1971. And then 26 years after he died, Titanic came out, along with a song called My Heart Will Go On. And here is audio of Louis Armstrong singing My Heart Will Go On. Right after this message. And right after this phone call.
There you live in my dreams. I see you as you. That is how you day go over. Far across the distance and space between us.
Okay, so it doesn't sound perfect, but you can hear that the lyrics are the same. So we talked about OpenAI Codex. It can create computer code based on user inputs, and it might take my job someday. All of these really, really cool ones are by the same company, like OpenAI Jukebox, GPT-3, and also OpenAI Codex are by this really cool creative company that I would love to work for someday. Okay, so now we're going to talk about computer vision, which is basically getting computers to see. So how does that work? This is an image, right? And so every image is made up of pixels, tiny little bits of information that are a single color, right? So this is one pixel, and it is, red 250, green 99, blue 150, depending on the brightness of each of those colors in that pixel. So this just gets represented as a number, right? So this is how we see it, and the computer just turns it into that, okay, 250, 90, 150. And so it doesn't just do that for one pixel, it does that for every pixel in the image. It does that for millions of pixels, right? And then we say, okay, computer, this is a cat. We label it. And so then the computer, after seeing thousands of this mismatch of numbers, it starts to say, okay, I think I see a pattern here. I think I see that this part is a cat. And then, when we give it a new image that it's never seen before, we hope it will detect that pattern again. Those mathematical patterns in the image pixels, and it will say, okay, I think this is a cat. And this is a special type of computer vision where we ask the computer to draw a box around whatever it detects. Okay, so another really interesting thing that you can do with this. So in this one, we ask the computer to detect a cat. But what if you turn it around? What if you say to a computer, hey computer, what does a cat look like? Give me an image of what a cat looks like. You're probably going to get something like this. I know, it's really bad, right? This this is what it looks like when you ask a computer what a cat is. But there was this really smart guy named Ian Goodfellow, and he figured out, hey, so if I kept asking a computer what a cat looks like, eventually I would get to a good image of a cat. But that would take me like thousands of tries. I would have to keep hitting no, 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 no. So he said, how about this? Why don't I program another computer to be the critic for me? I'm going to train one computer to generate cats. I'm going to train another computer to detect cats. And that detector is going to do all the work for me. It's going to reject, it's going to criticize until this first computer gets a good one. And so that's what this does. So you see, there's a first computer. Yes, so there's the first computer that says, hey, I made a cat. And then the second computer says, bro, that was terrible. So they keep going back and forth, and this computer keeps learning over time. This guy's pretty much the same. And then after thousands of iterations, this guy says, I made a cat. And then the second one says, that actually looks pretty good, bro. And see, this is a fake cat. This is not real. This is a synthesized image of a cat. And it looks really good. I mean, even if you got close up to it, I couldn't tell the difference. So, question. How many people recognize this man? No. Yes. I've had people lie to me and say that they recognize this man. How many of you recognize this woman? Nobody. Nobody. Good. Neither of these people have ever existed. They were created by a machine. So there's a website called thispersondoesnotexist.com. You guys are laughing, but I'm serious. This has been around for years. Yeah, it's super cool. There's also this cat does not exist, which is kind of hilarious. And then there are also like this room does not exist, this car does not exist. You can find all these websites online. So every time you go there, it generates an image of a person. So I went there and it generated these images. So this is kind of an earlier model. So even though these people look great, they look real, you can kind of tell that they're not because look at her nose and look at her teeth. Her teeth are very misaligned from her nose. Her teeth are going off to the right, her nose is going off to the left. Also, in these, the background makes no sense. So, but other than that, they're difficult to spot because the hair is so detailed and they look really good. So I was super impressed when this came out. And the cool thing is, it doesn't have to be just human faces. It can be any image that you want, as long as you've got around like 10,000 of them. All right, so we did that. Oh, this one is really cool. Okay, I'm excited to show you guys this one. This one is called DollE, and it was created by OpenAI. So what it does is it generates images from a text prompt. So it can generate from detailed instructions or really vague instructions. And it can also start from another image if you want. So I wish I could do a demo, but I can't today. So instead, I'm just going to do this. So what do you think I typed in for this prompt? I'll give you a hint. It is a song by the Eagles. Yeah, you guys got it. Hotel California. Okay. Now, what do you think is the prompt for this one? Hint, it is a song by Elvis Presley. Burning Love. Burning Love, you got it. Wish I had candies to throw out for you guys. All right. How about this one? Close. It's an Otis Redding song. Yeah, there you go. Sitting on the dock today. Okay, so the coolest part about this is you can generate art en masse using this program. So what I did one day is, I've been a songwriter for a long time, and I've got hundreds of titles that I've never used. So what I did is I programmed this program to just loop through my song titles and create one image for each of them. And then I just walked away. And then when I got done, I had hundreds of images that looked really cool. And so I happened to post it to my Twitter every single day. So it's really cool to create art on demand like this. And it's amazing how fast it happens. You know what, actually, no, I can't do that. I was gonna have like an audience prompt and then create one, but then I'd have to log into my Gmail account and everything. And I think that'd take too long. All right, so object detection, we talked about this. Draw in a box around objects in an image. So this is getting really, really fast. Like something like this is called YOLO. The program is called YOLO. You only look once. And it can do around 22 frames per second. So that's pretty fast. They still aren't super accurate, but they're useful for things like drones for targeting or detecting squirrels in your backyard. Like I know a guy I saw a video of this guy who used this kind of program to detect when his neighbor's cats were pooping in his yard. And then when they were, he would turn on the sprinklers, and then it would spray it out. So that's a good use of technology. Okay, so then we have image classification. Image classification is different because it's classifying the entire image rather than objects in that image. See, for instance, it says ceiling dog 98%. Is 98% sure that this is a ceiling dog? All right. And instance segmentation it's like object detection. Remember where we draw the square around the object, except it labels every pixel in the image, right? See, this man is labeled red, and it's saying, I think this is a man. And the road's purple, I think this is a road, cars are blue, street signs are yellow. So this is a little bit slower, but it's still pretty cool, and it works very well. This is called pose estimation, where it sort of outlines a person's body position using this skeleton. It detects each individual part of a person's body. So I use this to create the world's first artificial intelligence air guitar. So when I strum it, it actually sounds like a guitar, and I can change the chords using my left and right hands. Actually, I'm going to try to play it and see if it doesn't ruin everything. See if it doesn't ruin Christmas again.
Writer once said, most people die with their music still locked up inside.
Oh, great.
After teaching 500,000.
All right.
Okay, so I made the world's first playable air guitar using artificial intelligence.
All right. Okay, so one of the coolest things about AI is it's so new. Any idea that you have for AI has probably never been done before. Like with the AI air guitar, I was just like, hey, this might be cool, and I did it, and I searched the internet very thoroughly. No one has ever done that before. So if you guys have an idea and you want to get into this, you're probably the first person ever to come up with that idea. All right. So another way that you can use this practically is for medical diagnosis. You can recognize problems in medical images like X-rays, microscope slides. You see here, it's the same object detection again, except they're locating something bad, maybe a polyp or something like that. Actually, I think maybe a year or two ago, they surpassed medical doctors. I think AI is now more accurate than actual professionals are. Okay, and another computer vision thing is used for recognizing 3D models and not just images. So you see here we have converting an image into a 3D model, and then converting like videos into 3D models. It's pretty cool. This is kind of a budding feature of AI, but what it's doing so far is pretty impressive. Okay, so Unity perception, synthetic data. Okay, so this is a little bit complex. So remember how we trained a computer on images of cats, right? What if you made those images yourself? What if you made those images in a 3D program? Well, it turns out you can actually do that. It turns out it's okay. You can use fake images of a cat and then train an AI on it, and then it can recognize cats in the real world. As long as you use just maybe a few images of a real cat thrown in there. But it really improves the results, and it's pretty cool. I did this myself with a fork. This is a real fork, and this is a fake fork. And so I made 10,000 images of a fake fork. It like rotated it around and changed the lighting and everything like that, and I did that all in like 30 seconds, right? And then, I spent like 10 minutes, taking pictures of forks on my table, and it actually worked. It was able to detect forks. I trained an AI on fake stuff, and it was able to detect real stuff in the real world. Okay, so vision transformers. So we talked about GPT-3, where it takes in a certain number of words and it predicts the outcome. It predicts the last word. So somebody had a great idea. They were like, hey, what if we put images through that thing? And so we get something called vision transformers, which are kind of state-of-the-art in terms of computer vision. They just came out really, really recently, I think in the last 2 years. So there's not a lot of code available to use them, but they're very, very promising because they can understand videos as well as images. Okay. All right, and Google MoveNet, this is another pose estimation, but this is way faster than any other ones in the past. It can do 30 frames per second, and it can run on phones and computers. Okay, so now here's the cool part, and the kind of scary part. This is reinforcement learning. So it's called reinforcement learning because, like, if you think about a dog, you reinforce good behavior by giving that dog a treat. So that's kind of reinforcement learning in a nutshell. You reinforce behavior that you want the computer to do by giving it a reward. So AlphaGo. So there's a game called Go, It is a really, really old game. I think it's like 6,000 years old, where you have these little black and white pieces, and you try to surround your opponent with your colored pieces. So a computer beat the world's best Go player in 4 out of 5 matches. So this computer learned from watching millions of human-played games. It learned from watching games over and over, and it learned how to play Go from humans. This is a really great documentary. I highly recommend it. It's a lot more dramatic than you would think a computer thing would be. So, all right, so then after this big worldwide event, which was in 2016, the same company, it's called DeepMind. They're one of the 2 top companies in the world making AI. So after that, DeepMind made a new game, or a new AI called AlphaZero, and it beat AlphaGo 100 to 1. So the interesting thing is, AlphaGo was trained on millions of games that humans played. AlphaZero trained by playing against itself. It never saw a human game. So it learned only by playing against itself, and it was actually much more effective than AlphaGo. So I thought that was super cool. A computer can learn by playing against itself. So MuZero is something that just came out recently by the same guys. It doesn't even know the name, it doesn't even know the rules of the games, but it learns those rules for itself, and then it beats the game. So I'm not entirely sure how it works, but it's pretty cool. It can play Go, it can play chess, shogi, and Atari. So probably pretty simple games. All right. Oh, this is a cool one. Okay, so OpenAI 5. They beat the world's best players in a very complicated role-playing game called DollE, Defense of the Nations. So what you do is you have these little guys, and you click and you make them attack the other little guys, right? So there's this team right here that is the best DollE playing team in the entire world. People make millions playing this game. It's crazy. It's got its own subculture. So they are the best team in the world, and they lost like a lot. They got their butts kicked by this AI. And then so all these fans all around the world, they said, you know, you guys sucked, you guys did it wrong, I would have done this, I would have done that. So OpenAI, the company that made this AI, they made it public. They said, okay, you guys go ahead and try to fight our AI. And so humans lost 99.4% of all games. So, and again, this is an AI that trained against itself. It had never played against a human as it was trained until, the day that it performed. So, all right, okay, so this is like the scary part. I told you about, Terminator is real now. So this is that part that I'm going to talk about. So it just came out recently that in 2019, the Turkish army used a drone. This is actually a drone. It's called a Kargu 2. The Turkish army used this drone to track down and kill one specific person. The Turkish army was not in communication with this drone while this was happening. What they did is they programmed it. They said, we want you to find this person, detect his face, and then go and dive bomb him and blow him, right? And after that, they launched it, and they had no further communication with it. So that's a whole lot like this. Skynet programmed this robot to go and kill who? Yes, John and Sarah Connor, right. So, and then they released it, and they had no further communication with it. The robot was autonomously going out to kill somebody. So, all right, so programmed to kill Sarah Connor, no further involvement or supervision. That's the main part of this. So, same thing, programmed to kill somebody specifically, no further involvement or supervision. All right, so what I think is the scariest part about this is it can lie and wait for up to 24 hours. So it can be sitting on top of a hill or on top of a mountain, just completely silent, doing absolutely nothing, not moving at all. And then it spies a target coming across, and then it activates and swoops down and blows up. I think that's a little bit terrifying, because I can just imagine kind of a dystopian future, where there's this colony of renegade humans driving down this desert road, and then, camera zooms behind this drone, and it just perks up and starts flying. Okay, so, and it has front-facing forehead. It's made in Turkey. So, okay, so, this is going to be my final point before I open things up for a Q&A. So, reward is enough is an interesting concept that came from DeepMind. DeepMind is the company that made AlphaGo and that made the world's best player in the game Go. So the concept is humans and animals and everything else that's alive on this planet have very simple goals. Our goals are to eat. Our goals are to survive. Our goals are to sleep, right? So trees, squirrels, people, all of us have really simple goals. We all really want like maybe 4 or 5 really simple things. But because our environment is so complex, we are forced to behave in intelligent ways. Like for instance, a squirrel, because the squirrel wants to eat. Throughout the year, the squirrel climbs up into trees, takes nuts, and hides them, right? There are plenty of other examples of animals who behave intelligently, like a cheetah. A cheetah wants to eat, so it will hide in a bush, and it will try to trick other animals, right? It will just lie in wait. When an animal comes close, it will jump out and attack the animal. So the idea is, if we can program a computer or a robot with very simple goals, but we can make the environment complex enough, then a robot will behave intelligently. So I think that's really cool because it is just such a simple concept for making a robot as intelligent as a human, which is something that people have been trying to do for a very long time. All right, so my name is Tyler Stewart. If you'd like to email me, my email is tylerstewart@gmail.com. I'm also on LinkedIn, so that is kind of where I communicate with people most. Okay, so questions? Yes? Yes, so the question was, have humans learned anything from the way that these machines play that beat humans? And the answer is yes, actually. So some players who were playing Dota, Defense of the Ages, the strategy game where you click and attack, some professional players would watch those games over and over again, and they would learn things from the AI. They would learn, okay, so I need to build these buildings first, and then stack a wall up here, and then I need to pull players back individually. So yes, that does happen. Next question. You in the back.
So how easy is it to do all of this? Is this going to be available to the public or only to a rich few that can afford to implement it?
That's a really good question. So this is, anybody can use it. It's there online. All this code, everything that I've showed you is free online, but it does take some studying to learn how to use it. It's important to learn how to code in Python. Sir, you had a question? I'm sorry?
Has an AI program invented anything other than the materials you mentioned earlier?
Probably. I mean, I used it to research Coville a little bit. I don't know if that particular AI has been used for anything else. I think they were using it for drug discovery, but I haven't heard any news based on that. Yes. The question was, I talked about MAT2VEC, the program that was used to find new thermoelectric materials. And the question was, has it been used to discover anything else? I don't know. I talked to the author, his name is John Dagdalin, and he said that they are using it for drug discovery, but I haven't heard anything else besides that. Yes, sir? Sure.
Okay, back in the early days of pre-existing computers, there were guys who set up a checkers program to play itself, and it got really good doing just that. So a lot of these techniques are new. It's gotten explored to be as a computing power.
Yeah, actually, that brings up a good point. He said that back in the day, years ago, they used a transistor computer to play checkers against itself, and it learned to be really good. So the concepts of artificial intelligence have been around for maybe 50 or 60 years, but it's just been in the last 10 years that we've had the computer power to try them out. Sir?
Which science fiction writer, in your opinion, best is
Which science fiction writer has best talked about AI? I don't think any of them have. Yeah, I mean, it's a really good question. I love science fiction. But if you were writing a science fiction novel about the reality of artificial intelligence, at this point, nobody's going to read it. Because it's just not at a place where it can be exciting yet. Yes, ma'am. Oh, well, I mean, the drone has a bomb on the front of it. So the drone pretty much just explodes as soon as it hits the person. So what was that? You know, I don't. The lady's asking what happens to this bomber drone once it detonates. I've seen the videos, and the drone is pretty much eviscerated. There's almost nothing left of it. So, yes, sir.
This is not an ad, but there's a book called Metalworks by a guy named Harry Bunn about thousands of these drones set loose. It's really, it just came out fairly recently, and it's what could happen if these drones were set loose. Highly recommend it. Harry Bunn, Metalworks.
That sounds really cool. A book called Metalworks by Harry Bunn. Yes, sir.
What was the category for the DollE using AI program? Was that case-based reasoning? What category was that?
The program that beat the professional players in DollE, that's called OpenAI 5, and the category is reinforcement learning. The computer learned how to lead a video. Yes, ma'am.
I'm trying to see if you address the rate of change. In other words, how long did it take to go from Go alpha, which beat 4 out of 5 humans, to alpha 0, which beat your
So she's asking the rate of change from AlphaGo to AlphaZero. I think AlphaZero was implemented just a few months afterwards. So the rate of change in AI is pretty fast. I mean, it's just people coming up with new ideas. The world changes every 6 months in artificial intelligence. Like if you'd asked me 2 years ago, can we generate images of people that look real? I would have said no. And then like a month later, that happened. You know, so pretty impossible things are happening every day. It's really cool. Yes, sir.
Yeah, so regarding that thing about this person doesn't exist.com.
Yeah.
In my job, I've had a lot of training for the hell out of me in how to recognize fake websites and phishing, spear phishing, all this stuff. Has anyone, any dark players yet started something like this website doesn't really exist to trap people?
That's a really good question. There is this website does not exist. That is the thing. You can click and it'll generate an entire website. There's this resume does not exist. So there's a lot of generator things. There are things called deep fakes where people will make a video and pretend like it's them. Some people do this where they'll do a Zoom call and they'll have a face over there to pretend to be like President Trump or Elon Musk, and then they'll get money from people. So I heard of another story. You can duplicate somebody's voice. You can just take a 10-second record of their voice and you can duplicate it. And I've heard of people duplicating the CEO's voice, calling the accounting department and telling them to send a check to this scammer, right? So any technology that's out there is going to be used for good and for bad. Yes.
Is there any field or aspect of life where artificial intelligence will never match human brain?
Oh, that's a really good question. The question is there any field where artificial intelligence will never match human brain? I don't know. Okay, so right now, artificial intelligence can create beautiful art, right? But it does not know what is beautiful and what is bad, right? I can create, 1,000 images, but only I can pick out which ones are beautiful. So I think maybe individual taste and sense of beauty are something that AI will never get. Yes, sir?
I got into trouble once using a photograph in my blog that had been copyrighted.
Okay.
If I were to go to this person does not exist and use one of those photographs, does it even overlay?
You do. You created it. The question was, so what if you are using a photo on your blog that's copyrighted and you get fined for it? If you don't want to do that, you can go to this person does not exist.com. You can generate an image of a person's face and you can use it on your blog, and nobody can sue you because that image is not copyrighted. You created it. So, yes, sir?
In the early days of facial recognition, there was an attempt made to identify criminals by their facial features.
Yes.
So they fed a bunch of mugshots into a computer and a bunch of just facial shots of other people, and tried to get the computer to identify them. It turns out it didn't work very well, because what the computer was focusing on was in a mugshot, nobody's smiling. In a regular picture, they are. So the computer was focused on the smile to identify which was
That's a really good question. So the question was, the gentleman was talking about how in early efforts at facial detection for criminals, they had this problem where nobody was smiling in their mugshots, and they were using mugshots to train the image, or to train the face detector. So the face detector could not detect people when they were smiling, like during a crime, so it wouldn't work. That is a problem called overtraining or overfitting. So how do you know that you're not doing that? You just test it. I mean, there's no real way to break open a model and look inside of it. You just have to test it in the real world. So that's what you do thoroughly to make sure it works. And actually what you said about face detection for criminals, nobody's talking about it, but that happens all the time in the US. They're not allowed to do it, so they find sneaky ways around it. Okay. Yes, sir.
I would guess that probably couldn't identify hairless cats, for example.
If it had been trained on hairless cats, then it wouldn't be able to.
Here's my question. What kind of reward does a computer want?
Snickers bars. No, okay, so the question was, what kind of reward do computers want? And that's a really good question. So you program a computer so that it maximizes a certain number, right? So let's say I have a robot in the audience, and I have a basketball hoop right here. I can program that robot, and I say, robot, I want you to behave in a way that maximizes this number on the scoreboard. And so the robot behaves randomly, wanders around the room. One day it finds a basketball, throws it in the hoop, and then the scoreboard goes up. So then the computer learns, hey, if I repeat this behavior, then that number goes up. And that is the number that I'm programmed to maximize. Okay? So reward is just kind of, it's just a name for it. It's for what the program is, what the computer is programmed to do. Yes, sir.
I know that we're already using AI for evaluating current, engineering, comfort zone designs and cars and so forth. But are we to the point where it's self-learning to be the better engineer or design better tools, even? Until it hasn't been thought about in application.
Okay, so yes and no. I think people have used AI. I think at NASA, people have used AI to design certain parts, but they have not implemented those designs. Because, okay, so there's this particular program. It's called generative design. And what it does is, like, you say what you want it to do. You put in the parameters, and then it sort of, like, etches out this block of, like, maximum strength and minimum weight, right? And it's really weird because it looks kind of organic. It looks kind of like an animal skeleton. But, so generative design is really in its infancy because AI, believe it or not, is not very complex yet. So I think generative design has a ways to go because there are a lot of factors that go into designing things, and AI does not understand physics very well yet. Yes, sir.
So for our society, is generative design more cooperative environment rather than AI taking our job?
Yeah, actually it is. So the question was, is generative design more cooperative instead of AI taking our job? And the answer is yes. I mean, like even with the AI that I've used today, making songs, making art, I find that to be cooperative because I can generate 100 images and maybe 30 of them will be really good, and then I delete the others. And the AI, it can't know what is good and what is bad. And the same thing for generative design. You can generate something and you can be like, no, that doesn't work at all. You can do it again. And so you can tell the AI what to do, and then your job becomes selection rather than creation. Yes, sir?
What are the weaknesses of facial recognition that we could exploit to mess up the system?
Great question. The question was, how can we exploit facial recognition to mess up the system? So there is a whole thing online about ways that you can paint your face that will confuse facial recognition. The number one best way to do it, though, is be upside down. If you are upside down, they cannot detect you. It's the weirdest thing. I've tried it. I've done it with my own facial recognition. They never ever train these face detectors with upside down faces. So if the face is upside down, they will never detect you. So it's sad to say, but people with darker skin do not show up very well on face detectors. So if you paint your face black, that makes it easier. Yes?
Is there any interest for any attempt to use AI in investing and trying to come up with perhaps better results?
The question is, has there been any attempt to use AI in investing? I attempted it last night. I was not very successful. So yes, there's been, I think since the 80s, people have been trying to use AI investing with some success, some not. Yes, sir.
In the sound clip that you played us, was Louis Armstrong's voice sampled or generated by the machine?
It was generated by the machine. The machine learned from listening to many Louis Armstrong's songs. It learned that this is what his voice sounds like, and this is what that style of music sounds like, and then it added the lyrics of "My Heart Will Go On" to that sound. Yes, sir.
You mentioned that AI is not likely to be able to discriminate good versus bad art or whatever. Could it not simply analyze published pieces of art, art museums, things like that, come up with a definition of good?
Well, I think that's a good question. The question was, can AI analyze published art and museums to come up with a definition of good? I think that's a really good question. At the same time, what's good for you may not be good for me. Like classical art museums like bore me to tears, and actually like modern art kind of bores me to tears. I don't really like art. So I think it would have to be probably defined for each individual person. If I were to sit there and label like 1,000 images that I think are really good, then maybe an AI would be like, okay, I understand what type of things is really good.
Maybe the way to look at it is that an AI can be trained on some classic art style and become really good at doing that style. And if you didn't like it, well, tough. There are a whole lot of people who do like it. But that's the way real art works anyway.
Yeah, actually, the gentleman said that there could be an AI trained on classical art. There actually is. Remember when we talked about the face generator? Someone trained that on a lot of classical pieces, classical art pieces. And there's also a way to change your portrait, your face, into a classical art piece using AI. It's called style transfer. Yes, sir.
Do you know what the market is for this artificially created art?
Well, a lot of people are using it for NFTs. The market for artificially, well, I've seen it be in some galleries, like when AI was first coming out. He's asking what's the market for these artificially generated art pieces.
And then you kill the program and then you get rich because it's now finished.
I don't know. I guess it's kill the program, but I don't know. I mean, if I can figure that out, I'd make $1 million because I make AI art all the time, and nobody's ever come to me and said, hey, I'll pay you $1 million. So you let me know if you find out. Yes, sir.
With everything becoming a more, well, with deepfakes.
Yes.
Have you heard anything about CNN or credible news media using NFTs to register actual images?
No, I have not. That's actually a really good idea. The question was, are people using blockchain to register actual images like news media outlets? I have not heard that, but that's a really good. You should walk out of here and patent that idea and do a startup because I think that is a really good idea, actually. Yes.
Can you speak at all to the reliability of using, say, cycle GAN networks to enhance images? Like the amount, like if you train something, say with microscopy image, you have high resolution images and you have high volume images. Using that to train, do you feel that enhancement using that training method is reliable, and how many high quality training images you have to really get that to a usable image enhancement strategy?
Well, first of all, you're amazing that you know all those words that you just said. So I am familiar with image upscaling. I didn't know that it was done with CycleGAN. For me, myself, I've had some very bad results with CycleGAN. So CycleGAN is an interesting idea. What you do is you take 1,000 pictures of zebras and you take 1,000 pictures of horses. And so it knows the difference, and it can convert a photo from a zebra into a horse, and it can convert a horse into a zebra and vice versa. So I tried this myself. I tried converting people into marble statues. It didn't work very well. So I'm sorry, does that answer your question? Is there anything else I can?
I was just thinking about, like, if you train it, like I said, for my work, I'm trying to understand how to use this for image enhancement with microscopy. And so, like, how reliable do you feel it would be to take a really detailed image and then try to train it to, kind of like you were saying earlier with the, can you train it on cats and say generate a cat?
Well, yeah, I mean, that's a really good question. So what she's asking is there is something called image enhancement, where let's say you have a really tiny photo of your grandmother, right? And you want to blow it up really big, but every time you try to, it gets really pixelated, right? So there's something called image enhancement where you can do 10x and AI sort of fills in the gaps. So I think the question is, would it be better to train a general model or train a model specifically on the topic that you're working with? I feel that being more specific is always better. I feel like it would fill in the gaps much better if you train it on the types that you're working with. So the problem is if the data is too small, like a super tiny picture of your grandma, it's going to explode up and it's going to look nothing like her. It's going to look like a picture of Obama. I mean, they showed, I've seen this online where they took a pixelated picture of Obama. It was very, very pixelated, and they tried to do the super resolution, and it looked nothing like it. So there has to be some data there. Right, next question. Sir.
What's the name of the company that you wanted to
OpenAI, started by Elon Musk. There are two main companies who are the most genius and innovative in AI. There's OpenAI, which is kind of the happy, friendly, let's be creative. And then there's DeepMind, which I'm actually kind of genuinely concerned about what they're doing. Yes, sir. Nobody cares about IBM. They haven't really. I mean, I'm sorry, I shouldn't say that. But there are all these incredible breakthroughs coming out, and none of them are coming from IBM. So, I mean, like Google, Facebook, OpenAI, they're all just producing these amazing, incredible things. I have not heard of anything cool coming out of IBM except for quantum machine learning, but that hasn't really taken off yet. Yes, sir.
Since you're not making your millions using AI to make art, how are you making your millions using AI?
I'm not. The question was, how am I making my millions using AI? And the answer is I'm not. Yes, sir.
What kind of hardware does AI use?
Very good question. Really good question. What kind of hardware does AI use? So there are three types of hardware. Number one is your CPU, your central processing unit, which is present in every computer. A CPU is really good at doing one or two tasks very well. There's also something called a GPU, or a graphics processing unit. So if you have a computer game that's really, intensive, you would want to get a GPU. A GPU performs tons of tiny processes very well. And it just so happens that deep learning is tons of tiny processes. So if you have a GPU, you can train a deep learning model 60 times faster than if you just have a CPU. And then there's another type of hardware called a TPU that's 4 times as fast, but it's kind of difficult to use and it's proprietary and something like Google.
This is not something, we're not talking about hardware that we could go to Dell and buy, right?
Yeah. Mm-hmm. Yeah, I mean, you can just buy stuff off the shelf. It's just computers. So there's no special crazy hardware that you need to train an AI thing. Actually, you don't even need the hardware now. There are websites online that you can go to where you can rent the hardware and just use their website, use their hardware, and program it and get results back that way. Yes, sir.
Do you think AI could ever compose the ultimate melody that would be so hypnotic you couldn't stop listening?
The good question is, do I think AI can compose the ultimate melody that would be so hypnotic that I couldn't stop listening? I'm going to say that. What was that? Already done at Disney? So I don't think so, because I mean AI has to be trained on stuff that already exists, and there isn't really a song that is so hypnotic that you can't stop listening to it, at least not yet. So it would be trained on other songs. So, yes, miss.
Do Facebook and iPhone use AI for their facial recognition?
The question is, do Facebook and iPhones use AI for their facial recognition? The answer is you have to. There is no technology that can recognize faces that does not use AI. Like we talked about computer vision, recognizing cats and stuff. There's no real way to recognize somebody's face without using AI. So, yes.
Are they ever going to recognize you without makeup?
Oh. That's a really good question. So face detectors are not very good at recognizing women, or not as good at recognizing women as men, because women wear makeup, and these vision programs are very sensitive to color changes. So I think there are ways around it, like using heat maps, or like thermal vision, or maybe making things black and white. I think if all cameras upgraded thermal vision, I think that will improve improve accuracy. Yes, ma'am?
I'm wondering how successful AI is currently in recognizing the kinds of things we don't want to see on Facebook or Twitter, the kinds of things that are fake news or they're hate speech or that sort of thing. Is it getting better? Is there going to be interest in generating a better product?
Well, that's a really good question. So what you're talking about, the question is, moderating hate speech and nudity on Facebook, is that done by AI? So that's called content moderation. It's a whole field. I had a friend who worked at Facebook and YouTube, and her job all day was to label stuff as inappropriate, So it wasn't a good job, and a lot of people got like PTSD from it. But I think they're still working on it. I mean, it's still going. They're working on detecting bad stuff all the time. Yes. The question is, what do I do for a living? I have a cat. What was the question? Yes. Yes, my cat is a real cat, not a computer-generated cat. So, what do I do for a living? I teach a lot. I'm a mentor. I do tutoring, and I teach at a school called Magnamind Academy. And I also do projects every now and then. People hire me on the internet, and they say, hey, can you do AI for me? And I do some programs that way. Thank you for asking. Yes, Mrs. Back.
Okay. I have said for years that one day people are going to dematerialize and materialize someplace else, like they used to in the sci-fi movies. That's one question. The second question is that one day we may have smell-o-vision. We're watching the commercial on TV. There are brownies in the commercial. We can smell those brownies. Would you like to comment on those two things?
Yes. So as for the smell-o-vision, I thought about that yesterday. I have no idea how the nose works. So I can't really comment on that. I will say that bionic eyes have been invented. People have created a machine that transmits electrical signals through your eye nerve and can get to your brain. So I don't see why if we could probably create a machine that senses smells and then, puts it through your nose veins. I'm not sure. And the first one, could you say that again? What was the first one?
And I've said for years that one day we are going to dematerialize and materialize someplace else, just like for years they've done in sci-fi.
Okay, so that's a good question. I have no idea about beaming, but I will say this. There's a very famous futurologist. His name is Ray Kurzweil. He believes that in the near future, we will be able to upload our brains to a computer. We will be able to live in cyberspace, and we'll be able to email ourselves to another computer, right? So, pretty cool stuff. And actually, he predicts that within the next 30 years, death will no longer be a thing. Technology will be smarter than biology, and people will no longer die. Yes, sir, in the back.
What's your favorite fiction story, like Bubbaverse type when we talk about AI?
My favorite what story?
Fiction, like
Oh,
Bubbaverse.
okay.
Bubbaverse in that line, there's a whole genre.
Yeah, my favorite fiction story is Foundation series by Isaac Asimov. It's 11 books, and it's the best thing ever. I loved it so much, it inspired me to write my own science fiction novel. Yes, sir.
Can I do a follow-up question on smell-o-vision? I mean, smells are not a wave.
Okay.
Sight, electricity, radiation, they're all waves. And that's the problem with detecting smells and reproducing smells, which is what smell-o-vision would require. So getting closer to that when we have, what is it, printing objects?
3D printing?
3D printing. So it's using chemicals and depositing them. Those would be, that's an analogy. I mean, what you have to do is you have to create aerosols, or create particles in the air that can be spewed out. But you need reservoirs, you need mixtures and all of this. But AI could be trained, I think, to figure out the right mixtures, couldn't it?
Yeah, I mean, my question is not about AI being trained. My question is about the mechanics of it. Like, what equipment would you need to detect smells? Would it be like a mass spectrometer or something? I have no idea. Yes, sir.
So when you have classifiers, you get these digital output categories of it's this or it's this. When you have confidence levels, you might be able to say I'm 97% confident of what's this. But when you get analog medical readouts, like how much of this do you have in your blood level, you can tell if you're like 0.1 over or 0.100. Are there any approaches that
Yes, that's a good question. So we talked about how there are images and there are classifiers, and we have confidence for each. So what you're asking about is like, is there any way to use like a sliding scale, like how they tell your blood pressure is a sliding scale? Yes, that's called regression. So you can have your AI put out just a 0 or a 1, and that's like classifying into 2 categories. Or you can have it put out a number, like you can say, tell me what price my car should be. And then you would put in things like the quality of the car, photos of the car, how many years old it is, what gas mileage it gets, and then the output would be, how much you think the price should be. Yes, sir?
You alluded to kind of like the black boxedness of these networks, right? Has any progress been made in like analysis or self-analysis or that sort of thing, especially for like troubleshooting and debugging these things?
The question is like, I talked about neural networks as a black box. And if there's been any progress. So that is an entire field called explainable AI. I don't really care about it. I don't need to mean to you or to anybody. But for me, if the AI gives me a really cool result, I don't care like how it works. A lot of people do, though. A lot of people we want to know why this came up. So that's an entire field that I do not research. So, but if you want to look it up, it's called explainable AI. Yes, sir. Yes.
Where the drones were used extensively,
Uh-huh.
and Armenia got clobbered really bad.
Okay.
So, what are the chances of one of those rogue drones? Is there an international treaty that governs export technology?
Okay, so the question was, there was a recent war between Azerbaijan and Armenia, and which one Azerbaijan got?
Armenia got clobbered.
Armenia got clobbered. So Azerbaijan was using drones, like the one that we talked about, these autonomous killer drones, and they really hurt Armenia a lot. So the question was, will there be an international ban on this type of weapon? Maybe. I don't really know. There are a lot of people working on it. There are people protesting in Germany trying to get a ban on autonomous killer weapons. So I don't know if that will ever happen because drones are very cheap. And all you need to do is just put some explosives into a drone and then just fly it around. The programs to make it autonomous, that's a little bit more challenging, but not as hard as you would think. I made a turret that would follow my cat around and point a laser at him. And so it kind of follows the same principle. You just have to teach it to follow a human around and then pull a trigger instead. So it's surprisingly easy to make an autonomous killing machine. Next. Yes, sir.
Is there a chase between Chinese and the United States as far as AI technology?
Very, very good question. So the question is, how is China doing with AI as opposed to the U.S.? So in my opinion, China surpassed the U.S. In terms of AI implementation in 2009. Like, China is using AI in ways that we are not. So whenever you walk up to an ATM in China, it detects your face, and it makes sure that you are the right person. And it can detect if you are holding up a picture of somebody else's face over your own, which is something that we can't do right now. Also, when I was watching videos about the early pandemic, and China was flying over people's cars with drones and detecting their heat level, trying to figure out who has COVID or not. So, and they're also doing contact tracing. So I think China and the U.S. are on par as far as how far our technology has developed. But China is using AI a lot more than the U.S. is. Yes, sir.
So you could say that somebody who has a pacemaker is a cyborg because they're moving in robotic. With Neuralink, you're getting a lot closer and a lot more convincing to calling that person a cyborg. If we come up with these ethics laws of, well, you can't have this autonomous robot, but you can't have a cyborg who has an AI algorithm in their head, then you're going to be looking at the ethical questions of, like, we have cyborgs and how would we treat them separately than the algorithm?
Okay, so that's a really good question. So the question was, what about the ethics of being a cyborg? What if, part of you is mechanical? What if, you replace parts of your body with a computer? And the technologist, Ray Kurzweil, who I talked about earlier, said that it's already begun. He said that because you have a cell phone in your pocket, you're already a cyborg. you were already connected to the internet, you were already part of the machine. And so if people, become more machines, then I don't really see that as being a problem ethically, because I think everybody's going to be doing it at the same time. Like, we don't go around and like picket businesses saying, a cell phone user works here, and we don't have riots over people using their cell phones too much. So I think it's just going to be a gradual change that everybody goes through. Like when Neuralink comes out, I think as it gets to it, everybody's going to use it. Okay. Yes, sir.
Are there, in your industry,
Yes.
are there concerns about the ethics of privacy? You mentioned China having AI verify a face when you're using an ATM. My opinion is that that would never fly in the United States because of privacy concerns. Is that like a concern in your industry?
Very good question. So, yes, face recognition is illegal in San Francisco. San Francisco is like the tech capital of the world, and they are very, very concerned about face recognition. In fact, I think Amazon decided to remove its face recognition capability because it's so concerned about the use of technology. So, yes, privacy is a big concern. Yes, sir.
To help answer this question, if you know, you could talk about China's social credit report, or if you don't know.
I've heard about it, yes. My girlfriend is Chinese, and she says that she's never heard of it, which is really interesting to me. Yes, sir, in the back. Oh, discretion. All right, you. The what? Oh, Shazam. He's asking if Shazam uses AI. Yes, because it has to. I mean, there's no way that they wouldn't be able to, unless there's like inside of your phone, like a little bobber in a glass of water that goes up and down with the sound. I mean, there's no way for them to recognize music without using AI. Yes, sir. Ooh, maybe. I mean, right now that's a really, really risky thing. I mean, they would have to write it with the help of AI. I mean, if you tell an AI generate a policy for me, the first 10 tries are going to be complete nonsense. But maybe on the 11th one, it's going to be a good idea, right? So if they know what they're doing, like if you have somebody like Ray Dalio or Andrew Yang, I would say yes, but if it's just somebody who thinks AI is neato and they're going to try to figure it out, then I would say no. Yes?
Wouldn't it depend on the policy? I mean, at some point, it doesn't matter where it came from, it's here it is this a good idea or not?
Yeah, that's a good question. So the question was, the quality of the policy, it doesn't matter where it came from. I mean, if an AI generates policy and it's a really good policy, according to people who know what they're doing, then sure. I mean, I don't care if it's generated by an AI or not. Quality is what matters. Yes, sir.
You made the statement earlier that AI is not very good at physics.
Yes.
You don't mean the rule set geometry, you must mean, what did you mean by that?
Oh, good question. So when I said that AI is not very good at physics, what I meant is it doesn't understand the physical world very well. Like if you throw a ball, it's probably not going to be able to predict where that ball is going to go. So part of the problem is when we train an AI in a simulation, and then we put that same AI into a robot, the robot doesn't know how to behave. Because physics in a simulation are very, very different from physics in the real world. So we could train a robot in a simulation to walk, and it's really funny, by the way. When you train a robot to walk in a simulation, they walk around like this. It's super funny. But so anyways, if you put that trained brain into an actual real physical robot, it's going to trip and fall every time. It will not know how to behave because our simulations are not good enough to emulate real world physics. So that's what I said when I said AI does not understand physics. Yes, sir.
Isn't that simply a matter of hardware limitation?
That's a good question. Is it a matter of hardware limitation? It could be. It could be a matter of hardware limitation. It could also be a matter of software limitation. We just don't know how to program in the rules of the physical world.
So 3 months.
What's that?
So 3 months.
So
So it'll be ready in 3 months. Every 3 months things that double, or everything, the world changes in every 3 months.
Oh yes. It's possible right now, but wait 3 months. So yes, sir.
Do you personally have a comfortable distinction, definition of data processing versus AI? What's the balance?
Oh, that's a really good question. So the question is, what's the difference between data processing and AI? Well, data processing can be, you can just delete everybody's last name, and that's data processing. That's not really, it's not really too complicated. I think data processing is a bigger circle, and then AI, as I mentioned, is like trying to get a computer to do something that normally requires human thought. So, yes, sir?
Where do you feel liability lies for AI mistakes?
Ooh, that's a really good question. Okay, so I don't want to answer this, but I am going to. Yes, the question is, where does the liability lie for AI's mistakes? And I don't want to answer this, but I'm going to have to. So if I create a model, right, let's say somebody hires me to create a model that monitors street lights, right? That monitors street lights to make sure that they don't break down or something like that. And then there's a mistake in my model, right? AI is so new, there are always going to be mistakes. It is impossible for me to make a flawless model. So I would be on the hook. It would be my fault if my model does not work, but I don't want to be because it's kind of impossible to make it perfect. So I don't know if that's a good question.
Same problem as people.
What was that?
Same problem as people.
Same problem as people. Write a contract? Oh, that's a good idea. Get a lawyer to write something in there saying that I'm not responsible. Yes, sir. That's a really good question. So the lady up front mentioned that there has been, a dramatic increase in suicide rates, especially among teenage girls. And it's because they feel they don't look like these edited, doctored photos of other women on social media. And she was asking who is accountable for that. That is a really, really good question. I don't know how to answer that. I feel like I said, AI is still very new, and I feel like the people who create the AI, the company, the managers, they're responsible for it as soon as they learn about it. As soon as they know about it, they are responsible to make that change and provide algorithms. Okay, so we talked about reinforcement learning. An algorithm is made to maximize one specific thing. The Facebook algorithm is made to maximize the amount of time that you spend on the app. So it will show you whatever it thinks will make you spend more time on the app. And I think if they added another parameter, like maximize the well-being of the user, I think that would balance things out. Maybe make things better.
All right, it's only got time.
Okay, so that's all we have time for. Thank you guys so much for listening.